Good morning friends. During commissioning of HVAC system, due to improper selection of diffuser or we are not understanding few important points mentioned in the technical data sheet of the diffuser, we will face some type of design issues. Like you see here, my selection is based on manufacturer performance data, but I couldn't get proper throw as mentioned in the performance technical data sheet. Or I get higher noise level, however my selection is based on manufacturer performance data. Sometimes we will ask, I'm not sure that I followed the correct minimum and maximum distance between two diffuser. Similarly, for the special kind of project, you can ask the question like, I have a restaurant with open ceiling. I selected the diffuser based on performance data set but no proper throw and cooling. Instead of simply selecting the numbers like flow, static pressure and maximum velocity, neck velocity from some manufacturer technical data sheet, in this video I covered the technical points and its backup ideas, how each factors affect the diffuser selection. Let's start the video. A couple of things affect the throw and drop of diffuser is, one is whether it is free jet or whether it is moving along the surface like a ceiling. When you open the technical data sheet of any manufacturer, rather than simply seeing the technical parameters like the values, you have to have a look at the typical specification and the notes point what they have mentioned. So like you see in this typical specification, they have mentioned that diffusers shall have fixed horizontal air discharge pattern, and also you can see the throw. They have mentioned that terminal velocity is 0.75, 0.5 and 0.25. So like these are the important points we have to have a look before selecting the diffusers. The problem here is, as I mentioned here, if the diffusers are designed and tested based on ASHRAE 70 for the installation in the ceiling, and if we install the same diffuser in the open ceiling area, diffuser cannot produce its output as mentioned in its performance data of technical data set. Like you see here, this is the open ceiling area. It's a restaurant project and it's an open ceiling area. And I select a diffuser from the horizontal discharge pattern like I showed in the technical data set here. So here you can see diffuser shall have fixed horizontal air discharge pattern. That means this diffuser is tested with the ceiling. Okay, so when I install the same diffuser in the project where there is no ceiling, how the performance data set value I can get? That means if the same diffuser is installed in the place without ceiling, there will be 30% reduction in throw. If the performance data of diffuser indicates 4 meter throw, then there will be 30% reduction in throw distance. Generally, throw distance means how far the air jet moves from the center of the diffuser. If diffusers are installed in the ceiling, it will have surface effect. That means the air will touch the ceiling first and momentum of jets carry the air further. So I will tell you what is this. So when there is a ceiling, air discharges from the diffuser and it follows the angle pattern of the diffuser contour backpans. That means here you can see these are the lower blades we have in the diffuser. So when the air touches like this, it follows these angle patterns. Okay, and during the discharge of supply air through the ceiling diffuser, due to high supply air velocity near the ceiling surface, a small low pressure zone is created. Like you see here, the diffuser, the air is coming from here and this will be supplied like this, and during the supply of this one, a small low pressure zone will be created at this point. So due to this low pressure zone, what happens? A small low pressure zone is created along the ceiling and that pulls the air back towards the ceiling. That means in this low pressure zone, this pulls the air towards this point. So this is called as a Konda effect. So if the diffuser has internal Konda packet, like you see here, if the diffuser has internal Konda packet, it will make the air to discharge in horizontal direction even when there is no ceiling in place. This is useful to control the direction of discharging the air without a ceiling. So generally speaking, the diffuser will have the ceiling effect for horizontal throw data and there will not be ceiling effect for the diffuser with vertical throw data. So you have to make sure when you refer the technical data set, the performance data in the data set presented with the horizontal data, assuming that there will be a ceiling in place. So all the diffuser, most of the diffusers, when you refer, you have to see this technical data set because they are testing based on ASHRAE 70 considering the ceiling is there at the time of testing. So if you have some application that is without ceiling like the restaurant which I showed you, make sure that the selection is correct. Otherwise, there will be 30% reduction in throw distance. So the important point finally, select the diffuser based on application like with sealing or without sealing and verify the same with the technical dataset. And in this technical dataset, they have mentioned clearly that diffusers shall have fixed horizontal air discharge pattern. That means this performance dataset is completely based on the fixed sealing. So you are going to install the same in the open sealing, then there will be 30% reduction in throw. And the second point you can see here is they have mentioned in the throw terminal velocity is 0.75, 0.5 and 0.25 meter per second. So let's see how it affects the performance of the diffuser. As per ASHRAE 70, the throw terminal velocity must be mentioned in 3 velocity. Like we discussed now, 150 feet per minute or 0.75 meter per second, 100 feet per minute and 50 feet per minute. Like you see in this technical data sheet, air diffuser comes with a different pattern. Like you see here, this is single throw pattern, this is 2-side double throw pattern, this is 4-side throw pattern, and here they have given like a 4-way pattern, 2-way pattern and single way pattern. And the throw distance, you can see they have given 3 values. These 3 values are based on different terminal velocity like I mentioned here. So we need to know at what terminal velocity I need to select the diffuser. So before knowing this one, you need to know one important technical points. So here first we need to know what is the occupied zone. So like you see here, from the bottom floor level, the 6 feet height from the bottom floor level is called as the occupied zone, and similarly from the wall, means around the 4 side of the wall, 1 feet inside. So this zones which is inside means 6 feet height and 1 feet inside. So this zone is called as a occupied zone. So the air diffuser must not throw the air directly on the occupied zone. So now let's see how the air diffuser is throwing the air. Like you see here, when the supply air is coming out from the diffuser, it is not directly dropping in the occupied zones, that's 6 feet height, and instead of that, it touches the ceiling and it moves further along the ceiling, then it drops down. Okay, so the concept here is the air must not be dropped directly on the occupied zones. So for example, if you see here a 4-way diffuser pattern, they have mentioned 0.9 meter, 1.2 meter and 1.8 meter. So these are the throw distance. So here what they are trying to say, the throw distance means, like you see here the throw distance means is not from diffuser to this bottom of the surface, because the diffuser doesn't care about the occupied zones. Here mainly the concept they want to say here is the throw distance we have to measure is equal to A plus B. A plus B from the center of the diffuser to the wall, and B is this zone above the occupied zone. For example, this total height is 10 feet for example. Then the occupied zone is, as I mentioned, it is 6 feet. So the balance B is 4 feet here. Okay, so balance B is 4 feet here, and the total, the distance from the center to this wall is suppose 6 feet. Then the diffuser throw must be 6 plus 4 is equal to 10 feet. Okay, so we should not consider this 10 feet in this concept. Okay, so this concept is different. So as I mentioned earlier, the throw data is usually presented at a terminal velocity 150, 100 and 50 feet per minute. So like you see here in this image, from the supply air diffuser, initially the red one, it will come, the supply air will come with a high velocity 150 feet per minute. After that the velocity will be reduced like 100 feet per minute after some distance, that is indicated in the green one, and finally the blue one, you can see at the end it will be 50 feet per minute. So here I have given one good example. For example, here we have one package unit. From here the supply air is coming and it is dropped to the supply diffuser. And in this room I set a set point 24 degrees Celsius inside this room, and from the off coil means after the coil of the package unit, it comes with 14 degrees Celsius. So here it comes with 14 degrees Celsius, and here you can see we have 3 velocity. So first in this point it will be high velocity 150 feet per minute. So after some distance it will be 100 feet per minute, and finally it will be 50 feet per minute at this point. Okay, this region. So initially this one is the primary air, you can see here this is the primary air. So this is the supply air with the higher velocity will be here in the primary air. After that this point it will be total air. Total air means, so in this region it will be return air, means the room air will be there. Okay, so here will be supply air, primary air, here the room air will be there. So both will mix and it will make the total air. Okay, so that one, so here that one is like 15 feet per minute. T50 means terminal velocity. So terminal velocity 50 feet per minute. At this point, the total air means the supply air coming from the diffuser plus the room air, total air, is at room temperature at this point. At this point. So here the length of the horizontal throw, I mean this length, the length of the horizontal throw pattern along a ceiling increases when the supply air temperature is above the room temperature. For example, here we have 24 degrees Celsius. Here I told you it's coming with 14 degrees Celsius. If this temperature is high, then this horizontal throw distance will be increased. So like you see here, we have a package unit application. The off-coil temperature of the package unit was 14 degrees Celsius and the temperature at the diffuser, it was 16 degrees Celsius. And when it reaches the terminal velocity 50, this temperature will be equal to the room temperature. So if you have two diffuser in one room, then how to measure this one? I mean the throw. For example, the distance between the center of the diffuser to this point is 8 feet. Then you have to consider the half of this one, that is 4 feet. And I told you the occupied zone is, we need to consider 6 feet. For example, here the room height is 12 feet. So 12 minus 6, it will be 6 feet. 6 feet plus we need to add this vertical, this arrangement is 6 feet plus this horizontal distance we have to consider from the center to center. So it is 4 feet. So the total throw distance required for this room is 10 feet. Okay, so we have to select the diffuser. So the throw distance must be minimum 10 feet. So here the total horizontal and vertical distance traveled by the air stream is equal to the tabulated throw of the outlet. That means the performance data sheet outlet value, throw value. For high ceiling application, it may be desirable for the throw to exceed the space boundary, I mean the ceiling, and the travel down the wall towards the occupied zone. However, penetration of the occupied zone is normally we are avoiding that one. So finally, the outlet should be selected so that the throw at 50 feet per minute, that is important, not 100 or 150, 50 feet per minute terminal velocity equals required room throw, that is A plus B. Like I see here, A plus B should be equal, the throw one, it should match at terminal velocity 50 feet per minute. Okay, so in most cases, this criteria will produce acceptable results. So now the concept of throw is clear, and the ceiling, without ceiling, with the ceiling, that one, the discharge pattern is clear. And I think so now we need to see what is the minimum and the maximum diffuser distance between the two diffusers. When I install the supply diffuser very near to the return diffuser, it will make an effect called as a short circuiting. That means the supply air will not be discharged to the room. Instead of that, it will be collected by the return air diffuser. So when it comes to the minimum distance between the diffuser, so most of the time the people say it should be minimum 1 meter or 1.5 meter like that. But I will tell you one practical thing, then you can decide why the minimum distance of fixing is not possible always. So for example, you have one tile, you know that there are two type of ceiling, like a tile ceiling, gypsum ceiling. So we have a tile ceiling like this. So here in the center of this room, I install the sprinkler following the NFPA 13 requirement, minimum and maximum distance rules. And coming to the two end, the importance I have given for the lighting, that is a prime importance for the room because of the lighting is the appearance. And we have four tiles block left, 1, 2, 3, 4 in the corner and 2 in the nearby. So as per the cooling load calculation, I need to provide 2 supply air diffuser. So same matching the return one, I provide 2 return air diffuser. So I need to provide now 4 diffuser in this room, 2 supply air diffuser and 2 return air diffuser. So in this room, I don't have any option because already the sprinkler is there and the lighting is there. And the third important thing, I am going with the diffuser. So I cannot tell them that you have to move the diffuser, you have to move the lighting here, or you have to move the sprinkler here. So I can make proper minimum distance 1 meter or 1.5 meter. So this is the practical thing. So you need to understand that there is no fixed rule that minimum distance between these two I have to maintain or maximum distance I have to maintain like this, but it's practically it's adjustable based on the site. So you have to make sure that at least some 1.5 meter is possible to maintain. But if it is not possible, then okay, it's acceptable because it's a practical thing. We cannot fix the rule 1.5 meter always I have to maintain. So instead of my diffuser, you need to adjust the sprinkler. I mean that is not possible. So in this case, we have to have 4 diffuser, 2 supply and 2 return diffuser. So you know that if I insert 2 supply diffuser at this point, at this point there will not be a proper balancing airflow. So you have only one option to install the supply diffuser here, and you have to go with the return diffuser here and here. So like this, it is adjustable based on the site, and don't put no fixed rule. There is no fixed rule for the minimum distance between the diffuser. Okay, square diffuser. But practically, if possible, you can go with a minimum of 1.5 meter difference between two diffuser to avoid the short circuiting. And the third important thing here is the sound. So sound from the diffuser. As per ASHRAE 70, the diffusers are tested in 3 different cases. So the case 1 is the straight rigid inlet duct to the diffuser. So here, for example, you have the diffuser here, like I will show you here. So there will be straight rigid duct behind the diffuser. Okay, there will not be any flexible duct. So this is the first case how the testing is done based on the ASHRAE 70. So in this case there will be full flow and low pressure drop will be there because there is no obstruction like a volume control damper, nothing is there, and lowest sound level. So whatever the sound generated by the diffuser will be there, there will not be any additional. So plus 0 will be there. So data from this condition is typically published. So whatever the value you see here, you see there in the technical data sheet. For example, if you see here, the NC value they have given here in the technical data sheet at this point, less than 20, and here 22, 26. So all this value comes from the case 1 only. And coming to case 2, the same arrangement like this with the rigid duct behind the diffuser, but here I am adding the opposite blade damper. So because of the opposite blade damper, what will happen? The NC level will be increased 1 to 5 based on the flow and the unit size. Okay, so this is acceptable since we add the material obstructing the airflow. So coming to case 3, instead of rigid duct behind the diffuser, flexible duct is added with a 90-degree angle with some distance from the diffuser. If the distance is 3 equal in diameter, that means from here to this one, this is 3 into D. For example, if the dia is 20 mm for the flexible connector, then 20 centi, that means 200 mm. So 200 mm into 3 times 600 mm. So if the distance is 3 equal in diameter of the sound duct, then sound added is between 0 to 1 NC only. Okay, when the distance of the straight duct shortens like 0 equal in diameter, means this distance we are reducing to 0. This NC value will be increased to 6 to 9 NC. Okay, and coming to case 4, the same arrangement, but I'm adding the damper here. So in this case, what will happen? Damper increases the sound 5 to 8 NC from the baseline sound data. Baseline sound data means we just verified that it is like a rigid duct. Okay, so that is published in the technical data set. That's a baseline sound data. And same at 0 equivalent diameter, this NC will increase 5 to 10 NC value. So finally, the practical thing is what? The published data, technical data set is based on the case 1 value. Okay, so when come to the site, we are adding the dampers and we are adding the flexible duct with the arrangement of flexible duct based on the site condition. So finally the NC value will be increased like 8 to 10 NC will be increased. And another very important thing here is, in one room there will not be only one diffuser, there will be multiple diffuser. For example, if we have one room size 400 to 600 feet square, just for the example, if you have multiple outlets like multiple diffusers, then you can see the dB boost. That means the noise level will be keep on increasing if you are increasing the number of outlets in the room. So considering all these things, we have to select the noise level for the diffuser. So here I have given the recommended NC level for the different applications like office, hotels and schools and different thing, and the reference I have given here also. So considering all these things, now we will go with the selection of the diffuser. So we have an example here, like application is an office room, and required airflow based on the cooling load calculation, I have to provide 2000 cubic meter per hour airflow. Maximum noise level I consider from the ASHRAE recommendation, like here you can see here office building, and for the private office I consider 25 to 35 NC values. This will be between 25 to 35, maximum 35. So here the room size is 18 by 18 feet and the room height total is 12 feet. So as I mentioned, the occupied zone is 6 feet. So balance 6 feet I need to consider here. And total throw, that means this is the supply diffuser, this is the return diffuser is installed in the room. So from here I consider the maximum throw, that is towards the horizontal distance, that is here it is 14 feet. So the required throw distance should be this 14 feet plus this vertical B. The A means A is 14 feet and the B is 6 feet. So total throw for the diffuser should be 20 feet, and here I install the return diffuser. So here I show you one a technical data sheet from the KMC. So here they have given the neck size first. So the neck size we have to consider here. Like you see here, the neck size mean where the duct will connect here. This is the neck size, and this is the ceiling opening size. So this is not the duct opening size. This will be the duct opening size called as a neck size, because the neck velocity or terminal velocity is normally considered based on this one only, not the ceiling opening sizes. So here they have given different neck sizes, 150 to 150 till the maximum of 600 by 600 sizes square diffusers. So let's assume we have the four-way pattern, four-sided discharge square diffuser, and the important point here is the neck velocity. So neck velocity you can see this is different from the terminal velocity. So neck velocity it's like a 1 meter per second, 1.5 to 2.53 till 4.5 they have given. So the important thing here is if your application is like a normal residential or commercial office building or normal malls, this type of thing, you can select the neck velocity maximum between 2 to 2.5 meter per second, not exceeding 2.5 meter per second. 2.5 is maximum. And if you have low noise application like the library and museum, these things, so you can go with a low neck velocity, but like 1 meter per second, like that. And for normal application 2 to 2.5 meter per second, but not exceeding 2.5 meter per second. But if your project specification, the client requirement is low neck velocity like 1.52 or whatever it is, you have to give the priority for that one. But if it is not there, then you can consider the selection maximum 2.5 meter per second. The second important thing you can see here is the static pressure. This is one of the important thing. So PT means the static pressure. They have given the value in Pascal here. So 2.5, 5, 10, 15 like that. So the maximum Pascal you can consider like a 10 Pascal. It's a practical thing. We are normally following that one like that. So if it is the thing like if it is not mentioned particularly in project specification, you can consider maximum as 10 Pascal. And CMH is airflow cubic meter per hour they have given, and NC value like I showed you 25 to 35 for the office application we are considering. So we will just put your line here. So we will not cross this value because the Pascal value we fixed like a 10 Pascal maximum. 2.5 meter per second is acceptable, but the Pascal value is exceeding 10 now. So we are stopping at this point. So we need 2000 cubic meter per hour. So let's see one by one. So within this limit we are going to select. We don't need to see this one because it is exceeding the 10 Pascal value like that. Okay, so here this is going like 153 maximum, 374, 663, 1037, 1496, and here this is okay because we need is 2000 cubic meter per hour and this value is acceptable. So you have to verify all the point. So NC value is 20 is really okay because as I told you 25 to 35 NC is acceptable. However, we have some difficulties now in the deciding the power level here, sound level. Like I told you, this published data in the technical data sheet is based on the rigid duct. Okay, so in the practical thing we have volume control damper, we have the flexible duct. So surely that 5 to 10 or 5 to 8 NC value will be increased from what you see in the technical data sheet. So normally that allowance we have to give. For example, in our case 25 to 35 NC is the acceptable value, means we should not go to extreme edge 35. So we have to keep like 30 or 25. So 25 is the really recommended one. So in our case here is 20 only, so it's really acceptable. And the throw distance in our case it was like 20 feet, so that is equal to 6 meter. So here also you can see different terminal velocity they have given, 5.2, 6.4, 8.8. It is based on the 150 terminal velocity feet per minute, 100 feet per minute and 50 feet per minute. So like I mentioned, 50 feet per minute you can go for the selection. So again it is complying with our requirement of 6 meter or 20 feet height. So this is acceptable. So we can go with the 525 because again NC value is less than 20 and static pressure is 10 Pascal. It's really acceptable, good engineering practice. And velocity is 2 meter per second. I told you maximum 2.5 we can go. So this is again acceptable. So finally the 525 is the neck size. The ceiling size you have to match the opening. Okay, so this is the way to select the square diffuser. So in my next video I will explain you how to select the linear slot diffuser and grills with some technical backup points. Okay, instead of simply saying go to the data sheet select this value, you need to understand how it affects the technical points your selection. So thank you for watching the video. If you have any doubt, please add your comment in the comment section. We will meet again with another interesting topic. Till then, bye bye.